Welcome, everyone. Can you hear me? Good. So welcome. I know we're going to have a good percentage of the audience streaming in the next few minutes, but it's important that we begin. We have a hard stop at 5:10 or so. Sorry about that, but Johan does have to catch a flight. I don't want to risk him missing it and not being able to attend his activities in New York tomorrow. So we are going to start. I had a much longer introduction, and I have to say a much longer introduction is warranted for Dr. Rockstrom. But I'm going to cut it down so that I don't eat into your time. So welcome to the first fall event of our People and the Planet lecture series. I'm John Fernandez. I'm the director of the Environmental Solutions Initiative. We're thrilled to have you here. We're thrilled to have Dr. Rockstrom here. A special welcome to our partners around the Institute on the Environment, not only my faculty colleagues, sustainability initiative people, energy initiative people, and others, but also to our Conservation International partners who are also dotting the audience. We just actually, the last couple of days have been very eventful for us. We just held a Artificial Intelligence plus Conservation workshop, which has yielded a number of projects, and we're thrilled about that. So the Environmental Solutions Initiative is about that kind of thing. It's about solutions. It's about moving forward. It's about providing innovation space and opportunities for making the world a better place. Right? Okay, so that's really why we're here. The two fall speakers perfectly reflect that. Dr. Rockstrom, a leading scientist, I'll say a bit more about him in a second, but our second speaker is Senator Sheldon Whitehouse of Rhode Island, who will be joining us on November 20. That's the Monday of the Thanksgiving week. We hope you join us for that as well. Extraordinary politician, voice for climate action in government, very compelling speaker, so we hope you're there at that event as well. So I just cut through a whole lot that's really interesting, but I'm going to have to leave that for another time. So I'm just going to go straight to the introduction. Dr. Rockstrom is the director of the Stockholm Resilience Center, professor of environmental science at Stockholm University. He is well known for having led the team of scientists in developing and maintaining, operating, deploying the planetary boundaries framework, which he will talk about today. It's become a framework embraced by sustainable development, and it helps to guide governments, international organizations, NGOs, and companies who are in the business of making a profit, but doing it in a sustainable way. Before focusing at the planetary scale, Rockstrom's research at the beginning of his career was addressing building resilience in water-scarce regions, and as an expert in water resources after completing his PhD in Stockholm University Systems Ecology Department in 1997. So Johan, like Senator Whitehouse, is deeply embedded in his discipline and in his field, but is spending enormous amounts of time interacting with policymakers, and I'm not quite sure how you do that. Keeping a research program going and having a global impact and on the world stage with decision makers. So aside from his research, he is guiding policy. Rockstrom acts as an advisor to several governments and business networks. He also acts as an advisor for sustainable development issues at international meetings, including United Nations General Assemblies in New York this week, World Economic Forums, United Nations Framework Convention on Climate Change conferences, and is a member of way too many boards and committees for me to list here. He's also the recipient of a long list of very prestigious awards, a sampling of the French Distinction Knight of the Legion of Honor, the International Cosmos Prize, Zoological Society of London Award for Conservation Innovation for the Conservation International partners here, Woods Hole Research Center's Lawrence Huntington Environmental Prize, and many, many others. Please join me in welcoming Dr. Rockstrom.
Thank you so much, John, and it's a great honor to be here. And during the course of the day, I've had the privilege to interact with both many of you in the room here, students, PhD students, postdocs, but also with scholars here. And John asked me at one point, what mood are you in really with regards to the people and the planet? And typically as an academic, I couldn't really answer, good or bad. I gave him the kind of bit blurry, but I think honest answer that it is an era of scientific schizophrenia. There's never been such a high pile of scientific evidence of the global risks we're failing, but there's never been such a high pile of opportunity and actually light in the tunnel. And where this net balance ends up, I promise I'll give you an answer at the end of this lecture. So for the moment, I'll keep you in suspense. And what I'd like to do, and I kind of warn you here, I'll start with the pile of risks, but I then will transition over to the pile of opportunity. And let me just start, therefore, because I'll be going in the deep dive of the scientific evidence behind human pressures and risks at the planetary scale, which takes us to the planetary boundary framework. But let me then say that I come directly from New York and the first World Economic Forum Global Sustainability Summit. I have personally, and the Resilience Center, we've been engaging with WEF for many, many years. Frustratingly, to be honest, don't quote me here, but this is world leaders from business, from policy, and environment has largely, up until just 5-6 years back, still been on the sidelines of the little side events down in the corridor. But it's gradually been eating up higher up on the agenda. And yesterday, it was absolutely clear that we've passed a tipping point. That sustainability now is the key preoccupation and focus of the CEOs. Is no longer corporate social responsibility. In fact, Peter Bakker, the president of the World Business Council for Sustainable Development, the network of multinational companies that together represent more than 10% of the world economy, says clearly CSR is dead. There's no such thing now as environment being something for the head of the environment only. Sustainability is now a strategy for success. It's the pathway towards competitiveness. Your Governor Inslee of Washington yesterday and your Governor Brown of California positioned climate and sustainability at the position not only of reducing risks and getting humans' well-being, but it's also about competitiveness and the future of success and prosperity. And I just want to emphasize that that's where this lecture ends. And I'm, of course, you could argue, a naive academic, but I do continue as a stubborn donkey shot driver that scientific evidence plays a role in informing this tipping point that we're today seeing. So it's a very worrying time, but it's also a very exciting time. And I will start by saying that I think the absolute key positioning of all our science on integrated Earth system science is about a new narrative. It is fundamentally about reconnecting the world economy to the biosphere. It's about recognizing that this little thin layer of 20 kilometers of atmosphere that envelopes the biosphere on this small little blue marble is such an incredibly fundamental part of our world development, and that we are today putting all this at risk. And that this is the new narrative, which is not a narrative of us having threats on the planet, but it's the narrative of human survival on Earth and about ability to navigate a future for today 7.6, by 2030 8.5, and by 2050 at least 9, potentially even 10 billion co-citizens on Earth, all with the same right to good lives. So that is basically the entry point. You know the facts. I won't go through them in very large detail. I'll just give you the two most dramatic ones in my mind, which is that the latest Red List analysis of the International Union of Conservation Nature, you've probably seen it, projects that we are actually heading to a point where the 6th mass extinction, the first caused by another species on Earth, us humans, is putting it at a point that we're threatening by already in 3 years' time, have actually eradicating 67%, 2/3 of vertebrates on planet Earth. We are at a scale of undermining the potential for us to even produce food for the future of humanity due to erosion of biodiversity. And then we have the other kind of canary in the gold mine, which is the fact that we are today at 1.2 degrees Celsius global average warming. I'll excuse myself directly to say that I'll be sticking to Celsius. I'm sorry for that. You know that we are, to a large extent, having climate science indicating that we're probably committed due to the inertia in the climate system to soon 1.5 degrees Celsius, which is why the Paris Agreement is such a transformation. But remember that even if we are able to stay under 2 degrees Celsius warming, there are big Earth system components of the Earth system that would reach much higher temperatures. It was at the end of the presidency of Barack Obama who engaged very strongly in the Arctic, who launched the Glacier Initiative on stewardship of the Arctic, where in the White House this report was presented by US scholars saying that 2 degrees at the planetary level is actually 5 degrees at the Arctic. And I'm putting this forward to you for the simple reason that there is a lot of uncertainty in all science, in climate science as well. But there are some fundamental facts that we need to be communicating much more effectively, because even a climate skeptic would agree that 5 degrees is unacceptable. It is a place we haven't been for the past 4 million years. It is a position that would be clearly undermining the ability to provide any kind of human well-being or livelihood, and where we can actually cross tipping points of irreversible self-reinforcing warming if we lose the stability of one of the big planetary regulating systems, namely the Arctic, which is a great cooler of the planet thanks to its albedo and reflecting back 90% of incoming heat back to space. So already today, we know that we are in a danger zone with regards to some of these abrupt changes in the system. So the fundamental, to say, key message from science, I would argue, which kind of summarizes this whole talk, is that up until recently, we were still a relatively small world on a big planet. We have developed actually our world economy, our institutions, our governance systems, our nation-state logic, all our business plans, and all our kind of value systems, from exploiting here and creating pollution and basically relying on absorption capacity on the other end, our linear societal models, on this assumption that we are a small world and there's a strong big planet out there that can absorb in infinity. It has such a large resilience, it can actually take even some unsustainable management or economic logic. But we have so much overwhelming scientific evidence, and I'll give you a date on this, in fact, and I'll come to that, that very recently we flipped over and we have now become the relatively large world on a small planet. And that this may be the deepest insight and component in the new narrative for humanity's future on Earth. That we have, as Professor John Schellenhuber, the head of the Potsdam Institute of Climate Impact Research, states, reached a saturation point. We have actually filled up the entire atmosphere with greenhouse gases. Climate forcing is now at a point where we're reaching the 1.5 degrees Celsius level. We have overwhelmingly undermined 70% of fish stocks in the oceans. We have eroded biodiversity at a level of mass extinction. We've transformed 40% of the land area on terrestrial ecosystems into agriculture and urban areas. We've come to a point where you can start arguing that we have filled up the entire space. We have no choice now but to go 100% sustainable if we are to have any chance of delivering, for example, on the Sustainable Development Goals. So I think this is the kind of the key overarching narrative of this lecture. So the question then is, what's the evidence behind this new narrative? Well, you know it, certainly. It was in 2007, and I mentioned that date on purpose. 2007 is only 10 years ago. For the first time, we see the publication from the International Geosphere Biosphere Program, one of the programs that have now become part of Future Earth, the large global sustainability science community. I'm sure several of you in the room are part of Future Earth. Colorado hosts one of the hubs of Future Earth, by the way, of synthesizing the evidence of the hockey sticks of human pressures since the Industrial Revolution, 1750 in the West, the left-hand side of this x-axis, up until today. And here is just a small summary of the socio-economic driving forces, and you can see the patterns here, that up until the mid-1950s, we actually had very limited incremental increase in pressures, and then off we go, 10 years after the Second World War, we're 3.5 billion people, and we clearly put in the high gear of scaling the modern industrial metabolism. And off we go in the exponential rise from population, economics, consumer goods, and to say the whole socioeconomic fabric follows these patterns. And no surprise, the impacts on the Earth system looks exactly the same. You can pick any parameter that matters for the economy, for human well-being, and you have the exact same pattern. If you take the upper left-hand corner, the classic carbon dioxide hockey stick, in fact, the big mistake we're doing, it's as if that was the only hockey stick we have on the environment. It looks the same with regards to methane release, shrimp aquaculture, coastal nitrogen, eutrophication, all the way down to the one that I think we should be most concerned about, which is the exponential rise in loss of biodiversity. Up until mid-1950s, we had only incremental pressure. We were really the small world on a big planet, and then off we go in the hockey stick patterns, and we have this multiple range of hockey sticks moving ourselves towards a point where we today are the first generation to sit on an ample mountain of empirical evidence, observations, that we now are at this top of exponential curves, which actually continue to move in that direction. So you could argue that when Rachel Carson wrote Silent Spring in 1962, and when the Limits to Growth report came out in 1972, all of them kind of shot down very effectively by conventional economists and policymakers, you could actually argue today that they could be excused to some extent, because these were early warnings from insightful thinkers. But because we were just at the beginning of the curves, nobody could really know where the curves were heading. We were still in 1962 and 70s at this early stage. But today, we're sitting at the top of these exponential curves. We are the first generation with no excuse to act. With no excuse to act. Because we have today the empirical evidence that Rachel Carson never had, that was never out there when the fight was going on in that debate whether or not we were threatening to have silent springs because of, in that case, chemical industrial development. So that is insight number one. We welcome humanity to the Anthropocene. I think that's potentially the most important piece of scientific information to the world we have today, that we have, anthros, we humans, become a whole new geological epoch. We are now the largest dominant force of change at the entire Earth system scale. We're leaving the Holocene, the epoch that we've learned in school that we have been in since the last ice age, 12,000 years ago. And I'll come back to the importance of the Holocene. So that is insight number one in this story. Is this starting to be understood? Well, the answer is yes. And clearly, this is a very positive development, that this is coming out in the broader media, in the wider understanding. This is just a little kind of selection of these. You see how the French, typical gastronomic shows this as the French eaters eating up the planet. The first time it came out, actually, in the big public domain was when The Economist welcomed the humanity to the Anthropocene in 2011. That's that feature there. And I'm a big admirer of The Economist. It's actually a British weekly, as you know, and they have these fantastic British understatements in many of their articles, were so precisely and razor-sharply written. And it has a citation there which I think still reflects very much the mood among scientists, because it says as follows in this article about the Anthropocene, that, you know, when things are changing more rapidly than science stipulates it should, a certain degree of nervousness is a reasonable response. And I feel that that is exactly where science is. You know, when things are changing faster than we scientists stipulate it should, there's reason for nervousness. And that's exactly what The Economist put forward. And it's interesting that The Economist brought that evidence forward. So things are happening. And here comes the date then, that when did we reach the saturation point? Well, I think this is actually the frontier of science. That these are all the hockey sticks I showed in the previous graph, again with the x-axis from Industrial Revolution until today. And so I mentioned that we enter the Anthropocene. Actually, this date is now proposed by the Geological Committee at the Royal Society in the UK, you know, the entity that decides what geological epoch we're in. And that the date is suggested to be 1950s. Actually, in the end of the Second World War, with the first nuclear tests, to put it very precisely. So we enter a whole new geological epoch after the Second World War. But here comes, in my mind, the deepest insight. The Earth system is still so resilient at this point. In fact, we're still a small world on a big planet, So even though we've entered the Anthropocene, the system can still absorb so much of our pressures. There's still abundance of fish in the oceans. There's still atmospheric space to absorb more greenhouse gases. There's still no risk that lakes tip over. There's still ample rainforest to kind of continue unsustainable exploitation. But it is, when we come to 1990, if you look at the literature, that we start seeing the tipping point literature really kind of increasing. You see Steve Carpenter publishing the first evidence from the US of tipping lake systems due to overfishing and eutrophication, which led him to receive the Stockholm Water Prize, actually, just a few years back. It is now that you see the cod fisheries collapse out of Newfoundland, not far from here. It's now you see the accelerated melting of sea ice in the Arctic. It's now you see the first testimony of Jim Hansen in the Congress saying that we've passed 250 ppm in greenhouse gas concentrations in the atmosphere. It's now we actually have the first evidence that we at the Resilience Center actually identified that the Baltic Sea flips over from its oxygen, cod-rich, nutrient-poor state to its current algal bloom, dead state in 60% of its surface. It's now we start seeing flips in the system. So I think there is evidence to argue that we enter the Anthropocene 1950s, but still the Earth system is so resilient that it can continue to absorb unsustainable world development. But we reach 1990, and that's when we go into saturation point. And that's where we've filled up the whole system, and this is where science starts being able to observe the cracks in the system, the inability to remain strong and continue to absorb. And it is not until recently, therefore, not surprisingly, that the insights start falling into place, because you may have seen the UNEP report, it's now 10 years plus back, showing how the early scientific warnings has delays in action of roughly 25 years. There's a kind of a 25-year time lapse between the science being in place and the action. So it's not a great surprise that it's taken us almost a generation to really have insights falling into place from this initial tipping points in saturation science in the early 1990s. And it's therefore no surprise that it's not until now, over the past 5-10 years, we're starting to see the invoices coming, the surprises, that things are changing faster than we stipulate it should. And that we therefore also can argue that we should not accuse our political leaders or business leaders for not having acted very, very long time ago, or accusing the environmental movement for not having been more effective, because the reality is it's only in the last 25 years that we have reached the saturation point in the Anthropocene, and the first synthesis falls in place 2007. 2007, it's on the table. So there's something happening very recently. Now, do we have proof of this strength and resilience in the Earth system? Well, the answer is yes, and it comes largely also from science here at MIT, with the evidence of 95% of the heat caused by the climate forcing induced by our emissions of greenhouse gases stored in the oceans. The planet is blue, but it's also a thermostat that, in fact, when we measure temperature rise in the atmosphere, it's an underestimate of what's actually happening with the destabilization of the energy system, because so large parts of our climate forcing is stored in the oceans. I don't know if you've seen this back of the envelope, almost shocking number, but actually we've recalculated it and come to the same numbers. And I'm looking at you, John, to see if you agree to this number, that if all that heat that we have caused, which is now hidden in the oceans, would be released to the atmosphere, it would actually equate to a rise in air temperature of in the order of 35 to 36 degrees Celsius. 35 to 36 degrees. I mean, it's just an extraordinary, you could say simply, we would turn into Venus instantaneously. It would be an immediate, unlivable planet. Now, there's absolutely no science that would suggest that that could happen. In fact, the system is so resilient that it's absorbing this heat destabilization very effectively. But it's just to show what an enormous resilience the biogeochemical systems on Earth has. And that we have 25% of our emission of greenhouse gases every year stored in the ocean, leading to ocean acidification, but stored in the oceans, and another 25% stored on land. So we emit 9 gigatons of carbon each year, but 4.5 is pushed under the rug. I would argue the world's largest subsidy to the world economy, which we don't even incorporate or even admit. But I mean, the drama here is all climate models assume that this will continue. This is resilience in play, but what if we start losing this capacity? But it's a proof, a really hard proof, that the biogeochemical process in the Earth system applies all, so to say, Mother Earth can to try and remain in the Holocene equilibrium, and does so far very effectively. But it's not until in the last, just 20 years, we're starting to see the indications that this may reach the saturation point. Second insight is, well, if we are now putting such pressure, as Professor Will Steffen, for example, in Australia expresses it, that we're starting to hit the biophysical, hardwired processes at the Earth system level, the big question, of course, for us is, well, what is then the desired state of the planet for us to support human well-being? I mean, what state of the planet do we depend on, given that we're putting this pressure and we're in the Anthropocene? And interestingly, I would argue, and many scholars and peers and colleagues with me, that we can answer that question. Because there's so much data today from ice cores showing, the pendulum in and out of ice ages with its Milankovitch curves of 110, 120,000 years over the past quaternary, 2 million years, but in particular, how it looks on Earth the last 100,000 years. And I think this data coming from Greenland is so telling. And it's telling because on the x-axis here is 100,000 years, is such a well-chosen period, because we've been modern humans, modern, fully developed Homo sapiens on Earth for at least 100,000 years. In fact, much indications show that we went into our cognitive revolution of being able to really interact socially roughly 80,000 years ago. So we've had the same physiological and intellectual capacities of developing civilizations throughout this period as today. We were in deep ice age. It's the temperature variability on the y-axis. And as you see from the graph, we had a jumpy ride indeed during large parts of this period. In fact, temperatures could vary with plus minus 10 degrees Celsius over a decade. It was so jumpy, we were just a few million people on Earth, we were hunters and gatherers, and we had, to put it simple, a rough time. In fact, it was so rough that we know today from DNA-based paleo research that the low point there at roughly 75,000 years, when sea levels were 70 meters lower than today, when freshwater biomass was so scarce that we were hiding in the Ethiopian highlands as a last repository of human beings, we were down to less than 15,000 human fertile adults. We were virtually extinct, if the evidence is correct, as we have it today. We were so few that we can today actually state, which I think is quite an important reminder, that we're all very close family, because we started off with just 15,000 adults up in the Ethiopian highlands. And that this is a reminder of how rough it was in terms of the environmental conditions on Earth. And then we leave the last ice age 20,000 years back, and we move into the remarkably stable Holocene period. So stable that I've suggested to call it even the Garden of Eden. It is a period, an interglacial, a warm interglacial, with average temperatures on Earth fluctuating between plus minus 1 degree Celsius. And the reason why we know that this state is our desired state is that we barely enter this interglacial, and we do the most important innovation of all history of humanity on Earth. We become sedentary farmers. We invent agriculture. We come 2,000 years into the Holocene, and we domesticate animals and plants. And this is remarkable, and there's so much evidence to suggest that this was not a hevreka moment of one individual farmer suddenly waking up in the morning and saying, wow, what a good idea to plant a seed in the ground. Oh no, very much indicates that we had the technology. We knew it way back as hunters and gatherers. But what happened was that everything we love and depend on settled into the Holocene. All the biomes, all the forests, all the wetlands, all the grasslands settle in. Rainy seasons become predictable. Actually, growing seasons become predictable. Every year, you get 21, 22 rainfall events on the savanna. It starts in May, ends in October. Similar in the temperate zone in the northern hemisphere. You get temperature ranges exceeding 15 degrees Celsius every year, predictably, in a stable global environment. So suddenly, you see in Africa, in the Middle East in particular, domestication of maize, rice, teff, wheat, roughly at the same time on different continents. And last time I checked, we did not have mobile phones at that time. So we could not call each other and say, wow, what a great idea to start planting and domesticating. No, the agrarian revolution occurred simultaneously on different continents Why? Because the planet was such a Garden of Eden. It was predictable, it was low risk, we invested. And this was, the rest is history, as you all know. It was the starting point of civilization, differentiation, innovation, technologies, taking us to the point of the Great Acceleration in 1955. We're 3 billion people, we put in the high gear, off we go in the Industrial Revolution. We're still small on a big planet. We reached 7.6, we're committed to 9.5. And the conclusion from science, therefore, is as simple as it is dramatic, that the Holocene is the only equilibrium of the planet that we know for certain can support humanity as we know it. We can live outside of the Holocene. We've done it before. But we were a few million, we had a very rough time. We have no evidence to suggest that we could morally and ethically support 9.5 billion co-citizens with a minimum standard of good lives defined by the Sustainable Development Goals outside of the Holocene. So that's key insight number 2, because we're pushing ourselves into the Anthropocene, but we cannot leave the Holocene. And this, I want to sort this out because I many times get this question. How can this be? Isn't that a contradiction? It is not, because the Holocene is an equilibrium state. It is an equilibrium state of the planet. The Anthropocene is not yet a state. The Anthropocene is a geological epoch where we're the dominant force, but we're a force. We have not yet exited the Holocene. The big drama is whether we will or will not do so. And all the efforts we have to make is to avoid that tipping point. So of course, global risks is a key issue. And I'll just jump this very quickly. You've certainly seen it. Just a reminder that the pressures that we're posing in the Anthropocene is causing social, ecological disruptions already at 1.2 degrees Celsius rise. This is a paper that came out not so long ago, just showing how rainfall patterns, when they deviate at least 2 standard deviations away from the average, we see indications of larger interregional conflicts. We have the very debated, I agree, but still indications of how social disruptions such as the Arab Spring cannot be decoupled from global environmental change. It's not the primary cause, but it cannot be decoupled. Food prices went skyrocketing as a result of forest fires in Russia and 12 years of drought in Australia, which led to speculation in the world market, would hit back to Tunis and Cairo, putting the masses on the streets to an even larger extent, and there is an interaction here. So this is a new situation that we're seeing already now. You may have seen the effects of the latest El Niño event, which was very dramatic, I would argue, scientifically and also socially, because in 1998, when we had the last big El Niño event, we were many scholars in marine science saying that this was a disaster for the Pacific Ocean, for the Indian Ocean, and for the Caribbean, but the Australian barrier reef was resilient enough to cope. And many drew the conclusion that this was thanks to the stewardship of the Great Barrier Reef, with low sediment influx and sustainable tourism and protected zones and really high diversity of fisheries. Then comes the next knock-on, which is the 2015 and 2016 El Niño event, which was even more severe and which actually hit even the Great Barrier Reef. And this was the mapping by Terry Hughes and others at the Tim Cook University along the Great Barrier Reef, showing that 81% in the northern part, the warmer part of the Great Barrier Reef, was bleached and seriously affected in 2016. 33% in the middle and 1% in the colder south. This was a very serious piece of information when it came out. But the El Niño event did not leave. Even in 2017, so just a few months back, it was hitting again. And the coral reefs were not able to recuperate from the 2016 hit. So the assessment now, the latest one, the most recent one, is that 26% crossed the tipping point in the northern parts, 67% in the middle, and 6% in the south. The average is that 50% of the Australian Great Barrier Reef, the largest coral reef biome on planet Earth, has crossed the tipping point and is irreversibly dead. It's gone. Gone. And this is not communicated. In fact, it's not communicated also because politically it was so sensitive that it was put into a UNESCO report, because this is one of the man and biosphere reserves, And the Australian government erased the text. They did not allow the world to be informed that this tourist industry, which generates more money than the entire coal export industry in Australia. By the way, it's the coal export to India is being developed right at the Queensland part where the largest bleaching occurred. And this is so sensitive, so it's not even put out in the public domain properly. It's just to show you, or to remind us of how sensitive the Earth is to the risks we're now starting to face. And this takes me to the third and final insight, which took us to the planetary boundary science, which is that Earth system tipping points is a reality. So we're putting the pressure on the Earth system, and the big question is, how does the Earth system respond? And again, reminding ourselves that we've set up our socioeconomic systems on the assumption that we may have environmental impacts, but they are linear, they're incremental, and therefore predictable. That's why you can have discount rates. You cannot have discount rates as soon as you've had non-linearities. Discount rates then, so to say, do not work in the system. There might be some economists in the room here. We can have a little discussion on this afterwards. But essentially, the discount rate system assumes linear incremental change. But science has clearly shown in the past 30 years that the reality in the biosphere, in the Earth system, is the reverse. That actually non-linear change is normality, not linear change. But the reason why we have been able to build up a linear assumption is thanks to Earth system resilience. That over long, long periods of time, as long as we have redundancy and abundance of absorption capacity, biodiversity, abundance of species and resources, the Earth system can absorb and have linear incremental change. But up to a certain point, when the resilience is eroded and an incremental additional pressure can push a system across the tipping point, and we get an abrupt change. And the abrupt change is when a feedback shifts over from going from negative to positive. And as you all know, going from negative to positive feedbacks is kind of the scientific nightmare, because a negative feedback is a dampening feedback, but a positive feedback is self-reinforcing. So that's the nightmare. We don't want that to occur. And that tipping point is increasingly, evidence-wise shown to be normality. And we all know the fundamental tipping points regulating the stability of the Earth system, albedo being perhaps the most fundamental one. This happens to be just a picture from Svalbard showing how we want the Arctic to look like, a permanent white surface reflecting back 90% of heat to space. But when things start happening as we today see in an accelerated way, which goes faster than science stipulates it should, when you get color changes like here from the Arctic Sea, it gets darker, starts tipping over to be from a net cooler to a net warmer, and it self-reinforces warming. This is the drama that we see in permafrost thawing, when we can see the risks on albedo, which can see the risks of carbon sinks in oceans, on land. This is where the kind of flipping points are serious. And we don't even know what the effects are, for example, when the coral reef systems, as I mentioned earlier, which I would argue is the second cannery in the coal mine after the Arctic, the coral reefs, when they flip over into these dead zones, what are the effects on ocean capacity to take up carbon dioxide? We don't even know this. This is at the frontier of oceanography, but this is something that we cannot risk, I would argue. And I think we all, or many of us in the room here, share that there's so much evidence today on Earth system tipping points. This is our first attempt to synthesize a kind of a world map inspired by the Tim Lenton tipping elements map that came out already in 2008 on primarily the climate-induced risks of tipping points in the Earth system. I won't go through these. It's just to say that it's not only Greenland and the West Antarctic ice sheet. It is the evidence behind the risk from Carlos Nobres and their research at INPE in Brazil that rainforests can flip over and irreversibly tip over into a savanna state from multiple pressures, from deforestation and climate change. The monsoon systems related to the El Nino events and the ENSO circulation in the oceans, a whole battery of tipping elements that we need to consider as key components. And the drama here is a map that is not even published yet, that we're starting to see more and more evidence that when one system tips, it may have teleconnections which could tip over another system, and you can get domino effects of cascading tipping points where we don't know what the effects are. And this is again at the frontier. So for example, if we emit greenhouse gases from fossil fuel burning, and it takes us to, let's say, only 1.5 or 2 degrees Celsius, the big question, of course, is what tipping points do we then trigger, and are we at risk that the biosphere would push us to another level of warming? Big question. This, I think, again, is the frontier of science. And if you synthesize our level of knowledge today, it looks as follows. And I think this is the most important climate science graph we have today, actually, to communicate to policymakers. And it combines tipping points with the Paris Agreement, with the Garden of Eden. So here you have the same curve as earlier, but now just the last 20,000 years. So you see we leave the last ice age and we go into the Garden of Eden, the Holocene period. You have average temperature on Earth on the y-axis. Here is the Paris Agreement, which is to stay under 2 and aim for 1.5. Again, the reminder that climate adaptation will be, without any choice, a massive investment, because even the Paris range, even if we succeed, we're outside of the Holocene range. Here is the IPCC scenarios, and we all know with even implementing the current INDCs, it would take us to 2, 3, potentially 4 degrees Celsius, so we're entering this disaster zone. But here comes the key factors. At what temperature range are we at risk of pushing buttons of tipping points in the Earth system? And here is the effort from colleagues at the Potsdam Institute to summarize this. And what you see here in the column width is the uncertainty range. So clearly there is still scientific uncertainty of at what temperature ranges are we at risk of pushing key biomes and planetary regulating systems across tipping points. And I'll just focus on this square here, which is, this is the square, as you see, where the scientific evidence dips into Paris. Meaning that even if we succeed with Paris, we can no longer exclude losing the world's coral reefs. And I think that one is the most dramatic message, because if you look at the uncertainty range, it's within the Paris range, which is that we're very likely, unfortunately, to see a future without tropical coral reefs because of based on the evidence we have today. But then we have the alpine glaciers, Arctic summer sea ice, and you see that even Greenland dips into Paris. The uncertainty range is very wide, but we can no longer scientifically exclude, even though I would argue the risks are low, that we could push an on button of irreversible melting of the Greenland ice sheet, the 7-meter sea level rise that would entail. Not that Greenland, as we know, would melt overnight, but that we would irreversibly commit future generations for a 200-300 year period with irreversible melting of the ice sheet. So this, I think, is a really key piece of information that we need to be much better communicating with policy and business, that if you want to really navigate a prosperous future for humanity, the precautionary principle is absolutely fundamental. And don't make uncertainty or standard deviations a reason for inaction, basically. Okay, so this ends, I promised, the piling of the negatives. But let me then summarize this with what I think is perhaps a philosophical, perhaps a bit dramatic statement, but I'm convinced it's actually backed by science, which is that, so the evidence is clear. It is in the last 50 years that we have changed the conditions that the planet has been in for the past 10,000 years. But it's equally so that what we do in the next 50 years will determine the ability for humanity on Earth for the next 10,000 years. And it certainly doesn't go for all of you, particularly young people in this room, but in my generation, I've been around for the past 50 years, and I hope to be around for a better part of the coming 50 years. I mean, not the whole period perhaps, and this means that we are the kind of the determining generation. It's kind of us it depends on. We caused it, but we need to solve it. It's the tipping point right now, and it's we in the driving seat. What we did the last 50 years changed the past 10,000 years, but what we do in the coming 50 years determines the next 10,000 years. So this is a very challenging, but also extremely exciting time to live on Earth, because we are the ones, so to say, sitting there with all the knowledge and sitting in the driving seat to push ourselves forward. And this is therefore not a coincidence that it took us the planetary boundary framework as a first step, because it leads to an equation that I find to be the logic behind why we stood on the giants of knowledge over the past 30 years. Because if you combine the insights of the Anthropocene plus the Holocene plus the existence of tipping points, it leads to the obvious necessity of answering two questions. What are the environmental processes that regulate the stability and the ability of the Earth system to remain in the Holocene equilibrium? And secondly, can we, for each of these Earth system processes, scan off science and define quantitatively the boundaries within which we have a safe operating space for humanity on a stable Earth system, but beyond which we cannot exclude triggering tipping points that can push us out of the desired Holocene state? That is, in summary, the planetary boundary framework. So now the scientific frontier is actually, one of the scientific frontiers is actually right at this graph. It's also unpublished research. It's a graph done by Martin Scheffer, one of the leading tipping point scientists at Wageningen University, just illustrating that to map out the safe operating space, we must recognize that we're looking for what we can call a governed Earth. We need to stay within, we need to be able to define the planetary boundaries. What are the upper levels of change in the process that regulates the Earth system? And how can we, together, as humanity, govern and become planetary stewards to stay within this interglacial state and avoid pushing ourselves into a greenhouse Earth state that would self-reinforce warming to 4, 5, 6 degrees Celsius, but also recognizing that there is, of course, the glacial state, which, according to the conventional science, we would be entering in, say, 15, 20,000 years. But you may have seen Ganopolsky's paper from the Potsdam Institute again a few years back, showing that we probably already loaded so much climate forcing that we won't enter a new ice age. So it's interesting that our challenge today is governed Earth, which takes us to the planetary boundary science. And you may have seen the latest update on the planetary boundary research, identifying the 9 Earth system processes that, as far as we know today, regulates the stability of the Earth system. That these 9 is a reminder that it's an integrated system, and it's a system that, of course, has the climate system, the stratospheric ozone layer, and the stability of the global ocean energy conveyor belt, but it's also a system that depends on the slow variables in the biosphere, which do not necessarily have planetary scale tipping points, but they are working under the hood of the Earth system. They are the slow variables that grind and absorb and kind of function as insurance systems in the nitrogen phosphorus cycle, the freshwater cycle, the biodiversity, and the fundamental role of the terrestrial land-based ecosystems. And that these are fundamental planetary boundaries together with the big 3, the stratospheric ozone layer, the ocean, and the climate system. And that we have 2 final boundaries which are entirely alien to the Earth system, that are human-created. The chemical pollution boundary that we now call the novel entities boundary, the risk that we are undermining our genetic configuration due to loading of a whole battery of chemicals in the Earth system, and the whole aerosol loading, the risk of destabilizing, for example, monsoon systems and large particular climatic systems due to black carbon and aerosols in the atmosphere. And that we have, in our latest assessment, transgressed the safe operating space for 4 of these 9. The climate system is in an uncertainty zone. So the yellow zone is that you enter a zone which is within the uncertain terrain of science, but we are beyond the point of precaution. The range between the safe operating space and the yellow zone is actually the lower end of the scientific, our assessment of the lower end of the scientific uncertainty zone. I won't go through this more in detail, just say that this gives a guide for humanity to transform back into a safe operating space. And we are today at the frontier of science here. It's just recently an European Research Council grant was given to explore further the risks of planetary tipping points and how we can transform back into safe operating space. We're looking forward to collaborate not least with MIT. Let me just signal that out in Nature there is an advert for 4 postdoc positions and 2 PhD positions. So if you're interested, we'd love to poke through bright minds from MIT to Stockholm. It's a beautiful place to live in, by the way. So you're mostly welcome. And we have had great discussions today with John Fernandez and John Sturman about collaboration in this research of deepening our understanding of Earth system interactions, tipping points, and how to transform to a sustainable future. I am Thursday, Friday at the Sustainable Development Solutions Network, which is an initiative of exploring the transformative pathways of how to attain the Sustainable Development Goals by 2030. and to do that in a social, economically responsible way within planetary boundaries by 2050. Gathering the integrated assessment modeling community to start exploring the multiple pathways of innovation, disruptive technological, but also equity challenges of transforming the world to the sustainable future. Because we all recognize, in fact, that even attaining the SDGs is nothing less than an energy revolution, an equity revolution, an economic revolution, and a food revolution. In 13 years, we're supposed to have good livelihoods, decarbonized, not yet, but at least on our way to achieve it, for all human beings on Earth. And we are, for example, today deeply involved to connect great scholars here in Boston. In this case, I must admit, not at MIT, but at Harvard, Professor Walt Willett on public health with sustainability science to define for the first time science-based targets for healthy and sustainable food, which is part of this transformation towards a safe operating space in an Eat Lancet commission, which will be published for the first time in June next year. And the planetary boundary framework is increasingly being picked up and operationalized across societies. We have countries like Switzerland, like the Netherlands, like Sweden trying to incorporate it in its national governance. But we have also companies in big spheres trying to really place a planetary boundary framework as part of their strategic business model. We have the Action 2020 agenda, the World Business Council Sustainable Development, which again is not an environmental agenda. It's really about strategically recognizing that we now need to operate within a safe operating space in the Earth system. We're working with the Global Environment Facility, the investment platform in the United Nations, on how to now rethink the global commons in the context of planetary boundaries and the Anthropocene. The global commons being the externalities out there when we were still in a small world on a big planet, but now recognizing that all systems on Earth is actually an ethical birthright of all citizens on Earth, that we depend on stability in biomes to be able to have a good future. So we're redefining the global commons. And the new global commons is the fact that there is no such thing as an externality out there. The high seas or the atmosphere or the ice sheets, everything needs to be internalized within the nation-state economic logic, which leads to 3 principles of the global commons that we've been published recently in a report for the UN. And the first one is that all systems that regulate their system must be inclusive. There's no such, that is utopian, I know, but my finance minister in Sweden can no longer say that this is the GDP trajectory for the nation-state Sweden. The finance minister must be equally concerned whether or not the Amazon rainforest is stable, whether the Arctic is actually functioning, because all these systems are today interconnected and regulates the ability to produce jobs and growth in a small economy like the Swedish economy. It is also so that the principle of universality, it's a morality and equity issue. We have all the same right to the remaining safe space on Earth. We need to share the remaining finite carbon budget. And these are fundamental principles that we have not really at all operationalized yet. And we also must recognize that there is a resilience principle, that we now need to recognize that we cannot just optimize and make things so efficient as possible. We need to have a certain degree of redundancy in the system to be able to deal with shocks and stress in a turbulent world. So these are principles arising from this work and recognizing that the biomes are fundamental for all our human well-being. These systems are not only kind of nature protection areas, these are Earth system regulating systems that we depend on for our ability to remain in a stable Holocene state. This is very difficult mentally and kind of morally, but I think it's part of this new narrative. And let me just close with one success story then, or I think one way of translating this new narrative into something that can inspire innovation and technology advancement of exponential solutions. So we took the planetary boundary science and connected with climate science to ask ourselves the question, what does the Paris Agreement really translate to? And we found that it translates, interestingly, when you summarize the RCP 2.6, the representative concentration pathway, the only pathway that can take us under 2 degrees Celsius, it is actually following serendipitously a path that can be equal to a Gordon Moore-inspired law. Remember the Moore's law of doubling the pace of transistor speed, something that you know better than anyone on this planet, every 18 to 24th month. Well, if you look at the Paris Climate Agreement, it translates actually to a pace of decarbonization equal to a law that goes as follows. Halving emissions every decade can take us to Paris. Halving emissions every decade would be the innovation pace that can take us to success. Now, why could this be important? Well, to begin with, it originates from an innovation domain, the Moore's Law. But secondly, when you think of it, halving emissions every decade can be done at any scale. A nation can do it, a business can do it, you and I can do it. It is actually something that can be adopted immediately by anyone. And it was published in Science a few months back, and it originates from a summary of the journey to succeed with Paris. And it has this curve, which I'm sure you all recognize. On the y-axis is emission of carbon dioxide. This is just the carbon dioxide from fossil fuels. The roughly 40 gigatons we are projected to emit by 2020. We need to bend that curve in 3 years' time. Christiana Figueres, the former head of the United Nations Framework Convention, is on her quest for this movement in the world of bending the curve latest 2020. And then we need to follow a pathway that follows a carbon law of halving emissions every decade. So that's the gray curve of the carbon law. But that is not enough, as you know. Even if we do that, we would not succeed with Paris on its own. We need to transform, in the brown line here, food systems from a net source to a net sink over the next second half of this century. An agricultural revolution of large proportions, because agriculture is the single largest emitter of greenhouse gases. But that's not enough. We then have all climate science indicating that we need to go to negative emissions based on CCS and BECCS at a scale that is equivalent to the ocean sink today. But not even that is enough. We need to maintain the resilience in green and blue here in oceans and on land as high as possible throughout this century to maintain carbon sinks. And if we succeed with all this, we have a 66% chance of meeting the Paris Agreement. So it's just a reminder that we're in for quite a journey. And this is a global sustainability transformation, and it means that there's no such thing as Paris alone. Paris must be embedded within the SDGs. But it has a carbon law, and the carbon law is really exciting because it shows that if we can halve emissions every decade, we stand a chance of taking the first step towards decarbonizing the world economy by 2050, and thereby giving a chance to deliver Paris. Now, you may then ask, isn't this complete utopia? And my surprise to you, perhaps, I mean, it's difficult to surprise MIT faculty, I realize, on the following, but it might surprise you, who knows, that we are following the carbon law. We are following the global carbon law. And that's quite extraordinary. And it comes from data even from the International Energy Agency that has always been underestimating the pace of innovation. So what you have here is on the y-axis, the global energy mix. So 100% is all energy. It's not only electricity, it's all energy. And you see from 2000 to 2015, the current observations. And you see coal, roughly 30%, oil, another 30%, gas, nuclear, and hydro. And in a little sliver in the lowest part there, you have renewables going from 0.8 to 2.8% in 10 years. You know, this little, according to BP and Shell, this little ridiculous line, which, of course, we take climate science seriously, but you know, we have a responsibility to deliver modern energy to humanity. So this can never do the job. And in a way, they're right, because it is this little ridiculous line. However, it is doubling every 5.4 years at a global scale. And as you all know better than anyone, when you follow exponential curves, it happens very little in the beginning, but then it starts ramping up. So the first curve you see there is if we just go business as usual and just follow the current pace of renewable scaling, and we would then knock out coal in 2033, knock out oil before 2040, and reach a fossil fuel-free world economy by 2045. Business as usual. Now, an economist would immediately say, but you know, innovation pathways follow S-curves, or you're many innovators here in this room. So our big challenge is, of course, to break that, to say, let's see to it that we follow this curve throughout the first half of this century. If we would speed up even further, we could actually reach a fossil fuel-free economy by 2035. It's just to show that the light in the tunnel is real. We're following a global carbon law already today. Things are happening so fast in a disruptive way, and the technologies are actually available. we start seeing signs of planetary stewardship. We have the Sustainable Development Goals. The first time ever humanity has a roadmap for people and planet. We've never had that before. We have, for the first time, aspirational goals for social and economic equity for all citizens within planetary boundaries for oceans, freshwater, biodiversity, and climate. We have scientifically reconfigured this one a little bit because we feel that the world is kind of using it as a Swedish smorgasbord. You know, kind of you pick the goodies, and then you do a little bit on goal 16, or you do your favorite goal 4. It actually, I think, scientifically has support that it should be a wedding cake, but in fact, I had a graph before. Sorry. This is just to show that this is an enormous advancement because sustainable development was, as you all know, defined in the Rio Conference 1992 by my great hero Gro Harlem Brundtland as the 3 pillars of sustainability: social, economic, and environmental. And we must simply admit that this failed. It became what I call today a Mickey Mouse economy, that natural capital and social capital feeded the economic capital. That economic capital occurred at the expense of natural and human capital. And we must simply move away from this and put the economy, yes, can thrive inside the safe operating space of the natural capital. That's why we have scientifically translated the Sustainable Development Goals into a wedding cake. That the wedding cake is that there is some non-negotiables in the SDGs. The fundamental planetary boundaries in the bottom, the oceans, the climate, the land, and the biodiversity, upon which we can have social development, and where we have the economy as a key engine, absolutely key as an innovator driver. There's nothing hindering us to have the 4th Industrial Revolution propagated by the World Economic Forum, but it has to be domesticated within the safe operating space of a stable Earth system. And I would argue and challenge ourselves to say that that leads to even deeper innovation, because if you have that as a criteria for success, it becomes an even more challenge for the great innovators in the world. So this, my final slide, is the new equation. I think that Mickey Mouse plus wedding cake becomes success for us in the future. Thanks for your patience. I'm so sorry for
One question. So I'm put in the very difficult position.
Yeah, and I put him in the difficult position.
No. I'm having completely enjoyed the talk. Wonderful. But I can really only take one question, otherwise he's going to miss his flight. So, any questions? Sorry.
Hi. You gave a very compelling picture of the complexity of it all. And despite the sort of more optimistic ending, you did highlight earlier on how even the world coming together and the Paris agreements and all that, everything shows it's clearly not anywhere near a safe place. So I'm just thinking in terms of the social and political motivating power to push in that direction, to maintain that carbon doubling, whatever, curve, where do you see the political challenge, social or grassroots or whatever, creating its own little tipping point that becomes self-reinforcing? It's not always easy to lose the pessimism on that score.
Yeah. That's a very good question. I think there's, I would just summarize it in 3 challenges, I would say. I think there's no escaping the need for strengthened global governance, which of course is difficult in today's world to argue for. But I think we cannot walk away from the need to have, the Paris Agreement really implemented, the NDCs really updated, the General Assembly working so hard on the SDGs. That has to continue. The second is that we need to have, a global grassroots movement that continues putting pressure from below, and we need to have an interconnected social media alliance across the world on communities. But then right in the middle, I think we need to ramp up even further the innovation investments. I mean, the investments in in technologies and systems and solutions, which makes it possible for a transformation to occur, not in, as we've always assumed in the past, that we can only become environmentally successful if we're all environmentally aware and willing to pay more. I think we now have to recognize that the world has to transform in a sustainable way, which means that indifference, where the big masses simply just surf along a sustainable journey without even knowing that they're doing it, that it simply becomes so much more attractive and so much more cheaper and obvious to move in the right direction. So that's why I'm so optimistic that decarbonizing is something that we can do in the energy system, because it has this perfect substitution, for example. But I'm equally concerned, as I can sense in between your lines here, that the world of today is not pushing ahead in the pace that we need. I think there is an argument to say that it's not a question if we will be decarbonizing world economy, it's a question if we'll do it fast enough. I think that is a strong support. However, the fast enough is really put at risk. I think one has to be very clear upon that. I agree with you. Thank you. Okay.